All right, good morning, guys. Can I get a thumbs up that you hear me and see the board okay? Okay, so we are still working with the log properties. So we kind of spent the last, 2 days, one day, taking one log and expanding it into the sum and difference of many logs. Today we're going to do the reverse. Now they're going to give you lots of separate logs, and your job is going to be to condense them back to one single logarithm. So you only want to see the word log or natural log one time. All right, so now we're technically using the properties in reverse. If they are separated by addition, we can put them back together using multiplication. If they are separated by subtraction, we can put them back together using division, okay? And again, this only applies to logs that have the same base. If it was a base 2 log that was being added with a base 3 log, we would never put them back together. Only applies to the same base logarithms, which all of them are, but just in the future, don't think you can do this with any base log. All right, here we go. So my condensing tips, my putting them back together. If parentheses are around the whole problem or anywhere in the problem, just like PEMDAS says, do inside the parentheses first. All right, look to put individual exponents back up and then move logs back together using your multiplication or your division. And then you always want to simplify answers, okay? Now, I do want to specify that I have a couple extra problems that I hope I get to at the end because they are directly from your homework because their directions are a little bit different than what is normally asked. I just want to be able to discuss that. All right, but let's do some really easy ones in the beginning to kind of get a feeler for this. All right, so the directions say, write each expression as a single logarithm. So right now, I don't see parentheses that I have to do inside of first. I don't see any exponents or factors out in front that need to go back up. I literally have two base 4 logs that are being added. So if these logs are being added together, they can go back to being one base 4 log using multiplication. So I can rewrite this as the log base 4 of, if I was taking the log of these two things, I can put them back together as one log using multiplication. So now it becomes log base 4 of 5 times 3. And now we simplify. Log base 4 of 15, because that's what 5 times 3 is. And then the only other thing you want to check, once you get back to a single logarithm, at least if the logarithm is this simple, guys, do you know the answer to that log? Do you know 4 to what power gets you 15? No, it's a decimal in between 1 and 2. So we leave it as log base 4 of 15, since it's a log that we can't answer. Right? Nice and easy. All right, look at part B. If you have the log of 8, subtract the log of 2, these are two separate base 10 logs separated by subtraction, which means they can go back to being one log using division. So I can make this one log of this and that, so you are taking the log of, so 8 divided by 2. And then what is 8 divided by 2? That's going to be the log of 4. And now ask yourself, do you know the answer to this question? This is a base 10 log. 10 to what power is 4? I don't know, right? We don't know that. It's definitely a decimal. It's probably even negative. So now we leave it as log base 10 of 4. So very, very, very simple. That's what you do. If you have two logs of the same base separated by addition, they can go back using multiplication. Two logs of the same base separated by subtraction can go back to one log using division. All right, let's look at this one. So guys, I don't see any parentheses that I have to do anything in front of first, but I definitely see a factor in front of this log. So that means he's got to go back up as an exponent. So that would have been log base 5 of 16 to the 1/2 power. And then plus, he doesn't have any factors in front that have to go back up as an exponent. We can leave that. Now guys, think about it. 16 to the 1/2, really, who is that? Because we do always want to think about simplifying. 16 to the 1/2, guys, that probably started as the square root of 16. And who's the square root of 16? 4. So we actually want to write this as log base 5 of 4, because that's the most simplified answer to put. And then plus log base 5 of 7. So now I have two separate base 5 logs that are separated by addition. They can go back to being one base 5 logarithm. logarithm using multiplication. So it'll be log base 5 of this and that. So we multiply them together, and you get log base 5 of 28. And now ask yourself, do you know the answer to that log? 5 to what power is 28? I don't know, it's 2 point something, right? 5 squared is 25, so 2 point something would get me 28. So since I don't know the answer to it, we leave it as log base 5 of 28. Right, nice and simple, just take your time and follow your steps. All right, guys, look at part D. Now we have more than 2 logs that have to go back together. So if they're not going to use parentheses, then you kind of just start on the left like we always do, and you grab 2 logs at a time, try and put them back together. Now, if you notice, I'm only subtracting 1 log. That's okay. If you're going to subtract more than 1 log, we may have to factor out a negative because it may have been dividing by more than 1 factor. And I'll get into that in another example. But right now we're okay. So the first thing I'm going to do is take these factors out in front, put them back up as exponents. So this will just be the log of x plus the log of y squared minus the log of z to the 4th. All right, so now let's grab 2 logs. These 2 logs are separated by addition, which means they can go back together using multiplication. So that'll be 1 log of x times y squared is xy squared. And then we're still subtracting the log of z to the 4th. So now these 2 logs can go back together using division since they're separated by subtraction. So now it'll be the log of this divided by that. And there's your simplified final answer. All right, can I get a thumbs up if everybody feels okay so far? This is pretty basic, not too much involved. Everybody okay? All right, let me go to the next example. You all right, Liz? Good. All right, first things first. I definitely want to do inside the parentheses. Now they literally have parentheses that are telling me to, hey, over here, do inside these first, right? Just like PEMDAS would tell us. So inside, I look at these 2. He doesn't have any factor that has to go back up. He doesn't have a factor to go back up. It's 2 separate base 2 logs separated by addition. Let's put them back together using multiplication. So that'll be 4 times log base 2 of this times that. And then minus, guys, I'm going to do this right now. I'm going to take his factor of 3. I'm going to throw it back up right now. I know it's going to have to go back up. And just be careful. Don't lose your base of 2. Some students just get, in the heat of the math moment, and they keep writing log, but they forget the base 2. Don't lose your base. You don't want to get all the way down to the end of this problem and type it in on your homework and just put the word log in, not log base 2. All right, so now, guys, this 4 is in front of this entire logarithm, which means he's got to go back up as an exponent on all of that. So this will be log base 2 of AB, the whole thing is now raised to a power of 4, minus log base 2 of z to the 3rd. So now you have 2 separate base 2 logs separated by subtraction. They can go back together as 1 base 2 log using division. So now it'll be log base 2 of this divided by that. So that is a simplified answer. However, I always get nervous every year that your online homework will mark this wrong as not simplified. The top is all being raised to the 4th power. there's no adding or subtracting that's stopping you from just giving that power of 4 to each individual piece. So another more simplified answer might be log base 2 of a to the 4th b to the 4th over z to the 3rd. I don't think it should mark this wrong, but they might consider, oh, you didn't remove the parentheses and they could have gone away. So maybe that would be a more simplified answer to put in. So if you want to take a guess or a chance, I think you can get it wrong more than once before they make you change the problem. One of these is definitely going to be correct. I just don't know if your book considers this completely simplified as leaving it as AB, the quantity to the 4th power, okay? And again, it's real easy, just do that anyway. So that one little step makes it, a little less nerve-wracking than just do it. Okay.
Wait, Miss Hardy?
Yes, go ahead.
I'm sorry, where did you get the 4 again?
The 4 was in front as a factor.
Oh, okay. I didn't see that. I'm sorry. Thank you.
You got it. Thank you. Oh, it's so nice to hear someone's voice. Hi, Mark. All right, here we go. All right. Woo. All right, this is the one I'm talking about, where you may be, oh, was I allowed to do that? Is everybody okay? I was afraid I'm going to erase too early. Are we okay? I don't want to erase the board if anybody's still writing, because I know I'm moving. Everybody okay? Okay. Okay. So this is a pretty big one in the sense that it's got lots of separate logs that need to go back together, right? Our goal is to always rewrite this as an expression with just one word log. So guys, I have parentheses. Notice, there's this 1/2 factor in front, which just means that all of this was raised to the power of 1/2 at the start. So we'll figure that out at the end. We're going to do inside parentheses first. Now, do you notice? All of these logs are going to go half to back together. So inside the parentheses, it's not like I have more parentheses that say, hey, put these 2 back together first. No. So what we do is we start left and we grab 2 logs at a time. But hold the phone. Notice how you have this minus this log and minus that log. You don't want to start creating these complex fractions. You don't want to just make a division problem and then divide by another thing. So this minus, we're going to have to work that out, and I'll show you in a second. Right now, though, let's put these individual exponents back up. Okay. Right now, I can definitely grab these 2 that are separated by addition and put them back together using multiplication. So it'll be the log of this times that. Okay, I want to stop. Everybody okay so far? So what happens is, let's say that now you're going to have this log subtract this log, right? So you're going to have to put these 2 logs back together using division because they're separated by subtraction, right? So you will have essentially created the log of a fraction once these 2 go back together. Then you're going to have to minus this one, which means this log and this log will also go back together using division because they're separated by subtraction. And I don't want you now all of a sudden taking a fraction that you've already created from these 2 and now dividing it by this one and creating a complex fraction. So in the sense, the reason why it's minus is because this must have been a factor and we had to subtract all of it. So what I want you guys to do is factor out this negative. So it's going to be take out the negative and then what's left. If I factor out the negative, then a positive log y is left. And now factor out his negative and it's a positive log z to the 5th. And we still have another parenthesis from over here. All right, so now by factoring out that negative, you're going to be forced to put these 2 logs back together first using multiplication since now they're separated by addition. So now we're going to have 1/2 times the log of 3x to the 3rd minus, let's put these 2 back together. It'll be the log of this times this. So now they must have been attached. So now when I put these back together, I'm only going to create one fraction. This divided by this. All right, so now we can put these back together using division. It'll be this divided by that. Okay. And now the only thing we have left is now we have this factor of 1/2 that must go back up as an exponent on all of that. Now notice, the word log is never raised to that power. It's what you're taking the log of. Please don't include the word log inside of that. That's not being raised to the 1/2. Only what you're taking the log of gets raised to the 1/2. And guys, if this is 1/2, it probably didn't start as 1/2. It started as a square root. So it'll be the log of the square root of all of this. And now there's your final answer. Okay. So again, that to me that can get a little hairy because of the minus. If you're going to subtract more than one log, guys, it's only because whatever you're subtracting, these probably all go back as factors, which make one denominator in your division. Okay? All right. Let me see the next example. I definitely want to try and get to this homework problem. All right, let me do G, and then I should have time. I'm going to leave that just in case anybody's still writing, but at least I can start up here right now. All right, guys, right away I see these parentheses, and it's just silly stuff. 5 squared minus 1, guys, that's 24. It's 25 minus 1. It's literally 24. So let's clean that up right now. All right, 2/3 I know can go back up as an exponent, right? So that'll be the natural log of 8 to the 2/3 minus the natural log of 24. Okay, well, guys, 8 to the 2/3, simplifying wise, a fractional exponent is a power over a root. That's the third root of 8 squared. The third root of 8 is 2. 2 squared is 4. That's 4. Okay, well, now I have 2 natural logs separated by subtraction. They can go back together using division now. So now it will become the natural log of this divided by that. Which, guys, that simplifies. 4 over 24 is going to become the natural log of 1/6. So it's kind of like, wow, Hardy, that was a real easy one. Why are we working with that? I actually have to show you something, which I think when I first did this problem, I myself got it marked wrong. Because I wasn't realizing when they say simplify, just how simplified they want this. Guys, if you notice, you now have the natural log of 1 divided by 6 of a division problem. Our job was to put it back together, right? I did. But anytime you can create the log of 1, the natural log or the log of 1 is always 0. What base to what power is 1? It's always a power of 0. So if you can ever create a log of 1, you want to do that. So I'm actually going to split this back up to the natural log of 1 minus the natural log of 6. I get it. I would never have thought to do this because to me, I did what they said. It's the fact that we have a 1. The natural log of 1. E to what power is 1? Guys, that's 0. Any log of 1 is 0. And then minus the natural log of 6. So guys, what's 0 minus the natural log of 6? What's 0 minus 10? What's 0 minus 6? It's negative 6. 0 minus the natural log of 6 is the negative natural log of 6. And that's actually what they consider to be your simplified answer. I think it's an unfair question, but in case it pops up on the homework again, like I said, the problems are a little random. I just wanted to show you that. Now, I would argue that this -1 could go back up as an exponent. However, they're going to say, which I want to show you in some problems, to rewrite exponents as factors, which means some of them, they're going to want their exponents left down in front. And it's only if the directions say to rewrite exponents as factors. All right, I'm going to skip the last two examples. Let me show you this problem that I'm talking about on our homework. Oh, wait, I don't have to go here. Hold on. Okay, your homework is 7 questions long, so it's pretty quick, actually. Two out of those 7 questions have these directions. If they don't have these directions, then do exactly what we were doing on all the other examples. The directions say rewrite as a single logarithm. Okay, but then it says this, express powers as factors, which means they want any exponents. Try to make them become one exponent that you can then drop down in front of your final answer. So guys, look at this one, right? Seems easy enough. You're going to rewrite it as one log, get it all back together. Then you're going to try to create one exponent out of this problem that you can then drop down in front as a factor. So these are 2 natural logs separated by subtraction, right? So it will become the natural log of this divided by that. Yes, absolutely. I'll give filled in parts for all of this. So now, if this didn't have these directions, guys, you'd be done. This is a simplified one logarithm put back together using division. Because they want powers expressed as factors, now your job is try to create one exponent from this. So that means, really, the square root of x is x to the 1/2. Create an exponent out of that over x to the 7th. Well, guys, now I have a division problem, same base. I can subtract their exponents and make one exponent. So now this will become the natural log of x to the 1/2 minus 7. I'm trying to create one exponent on this problem. So then it's going to be the natural log of, well, guys, 1/2 minus 7, that's going to be what? 1/2 minus 14/2, right? If you get a common denominator, that's negative 13/2. Now that you created one exponent, you can drop it down in front as a factor. So now it's negative 13/2 times the natural log of x. You only have to do that on 2 questions when it says express powers as factors. I remember last year, a lot of students got caught on this one because they're like, this is right, I did this. They want the powers as factors in 2 of these homework problems, which means you're going to put them back together, try to create one exponent that you can drop down in front. Does that make sense? All right. Again, I don't like that kind of question, but it's on there, and I couldn't get it off out of the problem set. So just watch out for that one. All right. I have 5 minutes. We can do this. Let's do it. We're having fun. All right, look at this one then. Nope, that's not it. All right, so look at this one. Same thing. Rewrite as a single logarithm, express powers as factors. So this is, again, going to be one of those problems where you're going to get it all back together, try to create one exponent that you can then drop down in front. All right, here we go. It's actually not complicated in the fact that I just have 3 logs that need to go back together. So I can put these 2 back together first, since they're separated by addition, using multiplication. It'll be this times this. Okay, minus The natural log of, guys, x squared minus 16. My math brain's already going. I can see x minus 4s, x plus 4s. I can see the difference of 2 squares. I'm probably going to end up factoring that at some point, but I'll leave it for right now. Okay, so these cancel, and I'm actually left with the natural log of x plus 4 divided by x minus 4 when I fully multiply them together. Okay, now, through no fault of my own, I'm gonna have to create a complex fraction. So now I can put these two natural logs back together using division since they're separated by subtraction. So it'll be the natural log of this divided by that. And I'm gonna write that in his factored form when I bring them down. Right, so this divided by that, but I wrote it in his factored form, and it's all being taken the natural log of. All right, now we have to clean up this. So now I can times this by his reciprocal to get rid of the complex fraction. Right? Cancel, cancel. So now I have to times the top by that. All right, so what actually cancels? This cancels and this cancels. So I am now left with the natural log of 1 over x minus 4. Well, guys, if this wasn't these directions, we'd be done. This is a simplified logarithm. I've put it all back together. Now I have to try to create one exponent that I can drop down in front. Well, guys, I can rewrite this as the natural log. Really, one's just a placeholder at this point. I can take x minus 4 and raise it to the power of -1, which would then move it to my numerator. And now I have one exponent on this expression that I can drop down in front as a factor. And it's going to be -1 times the natural log of x minus 4. And there's your simplified one logarithm with the power expressed as a factor. There are 2 questions just like these on your homework. And every year I always say, oh man, I should have gone over that. So I feel better having gone over that with you. Does anybody have any questions? Is everybody okay? It's a lot. Everybody good? Okay. All right, so guys, you do have a day 2 homework on the condensing. It is 7 questions long. It's due tomorrow night at midnight. And then Mondays and Tuesdays problems, I apologize about the date being wrong. That was so my bad. They're due tonight. But if anybody has any trouble, please reach out to me and let me know. I'd be more than willing to help.